All right. Good afternoon. I'm Danielle Lazarus. My master's thesis utilized ArcGIS to analyze the current status of riparian land cover throughout Washington state. Historically, riparian buffers were naturally occurring, but Washington state has lost over 50% of its natural riparian habitat since the late 1800s. Riparian buffers are considered the most effective means of improving the health of salmon. It is a key means to provide shade for maintaining proper temperature for aquatic species, filtrating pollution, preventing erosion and bank destabilization, flood mitigation, and for nutrient and woody debris contribution that support aquatic and land species, including spawning salmon. Currently, there are no statewide standardized regulations for riparian management zones in salmon-bearing watersheds of all land use types, despite salmon species protections provided by tribal treaty rights, the Endangered Species Act, and water quality protection through the Clean Water Act. Voluntary riparian habitat restoration is also complicated by participation of private landowners. The debate between voluntary and regulated policy has been contested for over 40 years in the Pacific Northwest. This research project was inspired after reading the Lorraine-Loomis Act, which died in committee last year and aimed to create statewide standards based on the Washington Department of Fish and Wildlife's guidelines. This bill had wide backing from tribes and the governor, but was contested by agricultural groups. This year, House Bill 1720 was introduced, which aimed to provide funding for a completely voluntary program. While some collaboration increased between stakeholders, it did not include multiple tribes at a level of consensus, and it died in the budget committee. So key questions in the policy debate were whether the problem was a development problem or an agricultural problem, and whether the guidelines from the Washington Department of Fish and Wildlife, especially regarding the use of buffer widths at site potential tree height, whether they have a strong basis in science or can be applied on site-specific levels. So the science is actually key. In my research, I found hundreds of papers, which made it difficult to weed through, and reviews on the use of buffer widths. The Washington Department of Fish and Wildlife created handbooks for management with many consulting and internal scientists, and they were peer reviewed. The use of site potential tree height to 200 years is based on the FEMAT curves from a US Forest Service work group that was formed in 1993. And those guidelines were based on at least 20 years of research before that. Buffer science has confirmed repeatedly that a minimum of 100 feet is needed to filter most pollutants, and much wider than even the site potential tree height has been shown to have the most long-term benefits for wildlife and aquatic species. Okay, so this is just a summary of the guidelines. I wanted to point out that they do apply to all streams, regardless if they're salmon bearing, and regardless of their intermittent or ephemeral. So basically, I thought that providing the public and policymakers with current riparian habitat land cover data that requires measuring this size of riparian buffers and identifying areas that are lacking in relation to the best practice scientific standards. Most analysis is done on a smaller scale, but because of the policy debate, I thought it was valid to do a more statewide analysis. So a project using GIS analysis emulating elements of the regulatory policy that was requested, like in the Lorraine-Loomis Act, would be timely as a tool for policymakers. So basically, there were 3 steps to my methodology. The first, which was the longest was creating the base layer files. And one reason is that I had to merge 4 different hydrologic layers, a couple of which had millions of points of data. I had to join the site potential tree height layer to that data. I had to create the boundaries, including WRIA level. I also created buffer polygons. So I used the site potential tree height. Then I used the 100-foot to use as a minimum because of the research. And then I used 50 feet because I thought that was a more conservative number, and also it more replicates a lot of the more voluntary participation in riparian restoration. So then I used land cover rasters from the 2021 cropland data layer and the NLCD 2001 and 2019 data layers. And I was able to actually tabulate the information on a WRI level as well. I exported the tables, and then I did analyses in Excel and R. And I just have a few images of my map layers to share with you. This is the public lands in Washington. And this is a simple reclassification I did that was just developed agriculture and natural vegetation, or riparian. And this is the joined the SPTH layer. Okay, so what percentage of riparian management zones in Washington State are in riparian habitat land cover versus other land cover types? And I did break it out by private and public lands. Okay. The overall stats, this is just to illustrate the general composition of land cover in Washington State. I just wanted to mention that I didn't include water or perennial ice land cover, and I was also not able to collaborate with all Washington tribes, so I opted not to analyze their lands without permission. The main takeaways are that Washington isn't highly developed. It has a lot of publicly owned land, and most development and agriculture occurs on private lands, which might be obvious, but okay, and this is just the map layer. This is showing the 100-foot buffer of all of Washington State, reclassified to my simple classification level. And these are the overall percentages. I performed chi-square tests on the data, on the simple data. It's not great for getting a p-value, but it does really illustrate, it helps visualize the difference in the land areas between buffers. So this shows both public and private. And you can tell that, for example, the natural vegetation in the private land cover is proportionally higher in the 50-foot and 100-foot buffer prescriptions than in the SPTH. But on public land, it's actually higher in the SPTH as a percentage. So the major difference is this. I also did a reclass level that was not simple, because I thought that would give a lot of good information, which it did. The major differences you can see when I actually broke it out into Eastern and Western Washington, which was actually pretty simple using the WRIAs. You can see that agriculture is huge in the East. And then there's a big difference between the shrubs and the woody vegetation, which makes a lot of sense, but you'll notice that the public lands in the east actually have a much higher percentage of woody vegetation. And this is just a map of that, and you can see all that agriculture on the east side and the development on the west side. One of the most interesting analyses I did was using the Pearson's product moment correlations within the buffers. So I related the agriculture and the development land classes to the riparian land classes to see who is actually having the impact. And this was really interesting because there's very strong negative correlations between development in the West with a moderate level of agriculture as well. And the east side, it's almost all agriculture that's impacting it. This was really fun to make because it really helped visualize it, which is I broke it out by WRA using the percentages of riparian cover in the 50-foot buffer zone. I've also included the 100-foot and site potential tree height. The site potential tree height. But interestingly, there's minimal difference in the composition across the different buffer widths. So the map looks almost the same for each buffer width. I did another analysis of just looking specifically at the crop since I used the cropland data layer because I was curious about agroforestry in the buffer zone. And I found that in the west side, almost twice as many, there's almost twice as high percentage of perennial crops. So then how much land in these zones is actually currently protected? I was inspired by reading a Skagit County report that included this as a criteria for their analysis. And basically I used the National Conservation Easement database and the protected areas database, and 90% to 99% is conserved on public lands, less than 2% on private lands. I should say too that the NCED says that they are 90% complete in their data about private conservation. So then my last question was, how has land cover in the riparian management zones changed over time? And this is just, it's interesting to look at the percentages because they look really small, but that's why I included the acreages as well, because it actually does make a bigger difference than it looks like. It mainly shows an increase in development in the riparian buffer prescriptions. It also shows that if you look more specifically, it actually shows that the woody vegetation is increasing in the west and it's decreasing in the east. And also an interesting thing is the development levels overall are pretty similar. So what did I learn? Well, the west side actually has a pretty high percentage of potential riparian land cover in all the buffer prescriptions. There was no statistically significant compositional difference between the 50-foot, 100-foot, and SPTH buffer prescriptions. What that says to me, it was interesting to look at the 50-foot buffer because even though it wasn't statistically significant, it actually had more development in agriculture in some of the prescriptions, and that could be an indicator of needing to focus on that area while protecting the out to the SPTH. Obviously, there's a huge difference, the development in the west and the agriculture in the east, but most of the policy and the debates is focusing on agriculture. it may show that we really need to focus on that development issues in the riparian zone. Also, the east side is heavily depleted. There isn't as much research done on dryland riparian zones, so we really may need to also expand beyond that research that's heavily focused on forested areas. I also detected that most of the agriculture is hay or pasture, but there is a lot of research about grazing in the riparian zone, and it's mostly negative. There needs to be that research also done on the grassland or pasture impacts. It has very little information about its effect on aquatic species. It's mostly on pollution filtration. And then just the increase in the development and the crops in the buffer. So, yeah. Okay, I just wanted to point out that these data sets in the GIS were could be a little slippery. When I just changed a few things, it could change dramatically. However, I found using the percentages, it stayed very similar, no matter like if I made a little, even like a somewhat big mistake, it still stayed very similar. And I redid it like 3 or 4 times. So yeah. Okay. Lots of citations. Yeah, and then I just wanted to thank everyone who's working hard to improve the waters, especially the tribes who really do a lot of this work and have been doing it forever and in response to settlers. I also wanted to thank the MES professors and directors. I really learned so much in a short period of time. It's been challenging working full time, but it's been great. I also had a really great peer review team, Brian and Chris. And then also just everyone. I did some other really great group project collaborations. One person is in here. I really enjoyed that. And yeah, work and Hardy and Ariani. So yeah.
Any questions here?